Okay.
Good afternoon, friends. And Miss Nurul, today we are going to present about human vision versus computer vision. Here is my group mates. Over there is Lamin, Alfie, and then Edward. Oh yeah, my name is Cindy. Okay. The human vision, the human visual system, it comprises of three main parts: the eyes, the lateral geniculate nucleus or the LGN, and the part of the cortex, brain that processes the visual information, the visual cortex. Here is the eye, the cortex, and then over here is the lateral geniculate nucleus. Here is also another illustration of the human vision, the eye again, and then the brain, and then how it processes what it sees in the brain. So here's the image of fruit, and then it just goes straight to the eyes and then processes it as the object.
Yeah. And then here's the human's visual abilities, and it includes binocular integration, depth perception, hand-eye coordination, and visual pattern recognition. So we as humans, we have all these abilities unconsciously, and then yeah. So and here's a picture of our eye, which includes our retina, iris, cornea, lens, and other things, including also eye muscle here. And here's the picture of how we perceive objects. So yeah. Okay, so we have two parts here. This one's our left visual field and right visual field. So like, if we actually try to close our like right eye or even left eye, we cannot see the other part, the other side of our visual field. And that's how we, the way we perceive object is through our eye. It goes to our retina, temporal, and then it goes through our, like, mostly everything.
So these two eyes means?
It explains binocular vision, how we perceive objects using both of our eyes.
Yeah. Mama,
so this is the history of the human vision. So in 1959, the human vision was revealed by two neurobiologists, David Hubel and Thorsten Wiesel. In the 1970s, David Moore formulated computer vision to mimic human vision, and which is the basic of how computer vision visualized the human vision. And in 2000, the machine learning was introduced for the human vision, how they see the machines. So this definition of computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. And using digital images from cameras and videos and deep learning models, the machines can accurately identify and classify objects, and they react to what they see. So let's say, for example, we use those 6 image processing, pattern recognition, signal processing, and so the computer it gathers to the human vision what gathers.
Okay. So this is an illustration of how computer perceives objects. So there are different ways to perceive this. One, we have sensing devices. This can be a scanner, camera. So when the cam is pointed at an object, then within the computer, we have some functions to gather information from that, and we have the result. So, explain computer vision is a broad parent name for any computation involving visual content. This means how we process visual from images, videos, icons, etc. And in the object classification, we train a model on a data set given, and the object identification, that is, after classifying the result, then we can identify where that object belongs to. So why computer vision? Computer vision helps in many ways. Example, optical character recognition, vision biometrics, reading text from documents, scanners, etc. Yeah, object recognition, spatial effects, example in movies, sports, social medias, anything with story that allows you to wear something. Okay, go. So how computer vision works? So basically, if we have our object, that is the image, but before this we need to understand resolutions and pixels. So resolution refers to the number of pixels within a frame. So example, if we have 1920 by 1080, that means we have like 2,073,600 pixels on the screen. So each pixel represents RPG, that is red, green, and blue. So we have a table, and using the electron guns, those data are sent to, the electron gun shoots those images to the screen. Example, wait. So example, in spreadsheet, we have a computer screen. So we can give it a condition formatting like if in the screen or the pixel equals 0, don't display anything. But if it is equals to 1, then show that pixel. So this is our computer screen example. If this is 1920 by 1040, it means we have like 2,073,600 pixels to be shown on that screen. So the computer will start shooting from left going right. So if anything is 0, reading from this table, if anything is 0, don't display. But if it is 1, display. So the same applies to other colors, depending on the value of the pixel.
So these layers of the computer vision, the convolutional layer applies the convolution operation for the input, passing the result to the next layer. Pooling layer or the pool layer is introduced to reduce the spatial size of the output produced by the convention layer. The fully conventional layer is the layer in which every node is connected to every node in its preceding and its succeeding layer. This is the application of the computer vision. Smartphones, web, VR, AR, medical imaging, media, insurance. That's it.
Okay. So with computer vision, we are able to achieve many things. Example like image manipulation, etc. But in image manipulation, we don't really manipulate the image, you know, depending on the application. Example, if we are using Photoshop or another application to adjust brightness or saturation of an image, we focus on the pixels, that is the RPG. But if we want to maybe adjust the brightness, we pass that image to a function, whereby the function can be, if receive an image, add plus 50 to that and give us a result. But that does not mean we actually tampering the original image. We're just making a copy of the image to be shown on the screen. Okay, I think that's all from us.
Any question, guys? 2 questions, please. Yeah, come on. That's your job. Ayo, 2 questions. Yeah, 2 questions. One.
You mean that's mean what we see in the computers, what computer vision and the human vision totally different, and exactly like example like color, like we see color and computers see color, is it totally different? Because you said this use pixel, right?
Yeah, like what he said, how computer actually sees the color. That's like, I mean,
Yeah.
the one that shows all the.
Which one?
Yeah, this one. So like, how we see colors is that we can directly know that what kind of color is that. Probably it's white or something, but computer does not see it that way because they don't have the ability to understand what kind of color is this. But all they see is just numbers, which is put in an array, and then they translate it from the number to a color. It's like it is stored, like what he said, and what he showed in the Excel.
So generally it's like for every pixel consists of 3 colors, RGB, yeah? So 0 means dark and 255 means opaque, like max brightness. So within RBG you can get any color. So to get a pixel, I mean a value of certain color, you need to combine all these 3 colors together. So when you get that, then the value is placed somewhere, and the computer will, the electron gun will take that value and shoot it to the screen. So just example what I was trying to explain here. So example, the value for black here is 1, but we can add another value. Example, if equals to 2, so with this, okay, so this is our computer screen. Here, the electron gun will start shooting from left, top, going right, but using the table, values stored on the table. So if this portion is 0, it will paint it with the white color. And if 1, black, 2, again, 0, and it will start again. So we can achieve something like a box using this. So combination of these, you will get a picture or an image.
Thank you. Next questions.
Speaking on computer vision, you said their resolution, right? Do you think it's possible to define how, like, our eyes are analog and computers are digital, right? Do you think it's possible to compare the amount of resolution our eyes can see compared to the computers? If that makes any sense. So like a 50 megapixel photo, how would, how much is our eyes capable of capturing? If that makes sense.
I think depending on the person. For me, I don't wear glasses, so I can see clearly.
Right. So, okay.
But when Cindy removes her glasses, she won't be able to see you.
720p, right?
Is that the answers?
Yeah.
Yes? Okay, next questions, group 4.
So, can you go back to the slides where you convert it into the array of numbers? Yeah. So, is it actually converted into real numbers, or is it actually converted into other form of numbers such as hexadecimal or binary?
A tuple of decimal is RGB.
Why do you choose? Then why do you choose RGB as the? Why the computer vision use RGB as the baseline to convert those pictures into simple array of numbers?
Why? I mean, because RGB is the, actual, it holds all the colors, so combination of red, blue, and green, you get all colors.
It can be both because each number is from 0 to 255, so it contains about 8 bits, and if we turn to hexadecimal, so it just becomes half of it. So if you want to get white, if you want to get white, so you just get FF, and FF for the RGB. So hexadecimal you will get 6, but if you want to use the decimal in RGB, you just go from 0 to 255 for each part.
How? Okay. Okay. Next question, Felix, group 3. Just one question, please.
Okay. So what is it that makes human vision still better than computer vision? Or is it our computer vision is way better?
Human vision, we can quickly process it without needing much time in the computer, and then we can also automatically realize that, oh, it's a chair, while computer needs some time to process that it's a chair, and also needs some more data to know that it's a chair.
Okay, thank you very much for this one. Thank you, well done. Go.